going to talk about the ModelOps, model validation, to be more specifically. We are going to use a lot of open source tools for CI/CD, but we also will be using a few SAS-specific user interfaces just to demonstrate the end-to-end process. Okay. Maybe one more thing. We will present a demo to you. We'll give you a demo, and during that demo, we will also do a role play. I will be kind of the, let's say, the dev engineer, if you like, and Tamara is what she is. She is the data scientist. Yeah. Okay. Now let's get started. So our topic for today is, let's say, the broad heading for this is ModelOps, yeah, or as we sometimes call it, Operationalizing Analytics. And this is a picture that we took from a paper that was written by Google, and you see the link down here. It's an interesting paper that I can recommend for to read for you. So the interesting piece in this in this picture is actually the little black box that you see in the center, because when we think about analytics, we usually think about the model development part of the work, and this is, of course, this is the fun work. Data scientists are trained. They learned their job to actually do this little small black box, but in the reality is that there is much more work to do, and much more in the environment next to the development parts. And this is something that is usually not really taken into account. Yeah, this is something that we see with customers that we have often, and it's usually a big, it's an issue. Yeah, sometimes you call that the last mile. This is what needs to be done to get your work, your model, into a production environment, and that's sometimes that might be harder than developing the model at all. Yeah. So for today's session, we are not focusing on the fun part. We are focusing on the boring, grayish parts that you can see on this slide. Yeah, so we are going to talk about operationalizing analytics. And I'm pretty sure you have seen a picture like this before. Yeah, it's quite a common way of describing the way that model development, let's say, publishing works. Yeah, we call that the decision life cycle. So you start from the left, from the outer left, and you usually go through the steps that you can see here. Yeah, you start exploring the data, you start modeling, you register your model in a model registry. You have to do some validation steps. You might want to monitor or retrain your model at some point, and actually it's an infinity symbol in some kind. So at one point you are back at the stage to the outer left, where you have to work on your business problem again. Yeah, and this is like this is an ongoing process. As I said, for today we are going to focus on the center of this. Yeah, so we are not talking about the model development phase, and not about the data preparation phases. We are also not talking about these decisioning steps. Yeah, this is something that is more SAS specific. We usually think that a single model is not enough for a real world business problem. Yeah, a single model might not just fit the bill. There's something more to it. You have to take decisions based on those analytical outcomes. But anyway, for today, we are going to focus on this central piece of the picture. And this is actually also, this brings us to the topic of automation. And automation is a key requirement for anything that is, let's say, OPSy, and especially for model ops. Yeah. And on the left-hand side, you see the traditional approach. Yeah. This is actually, maybe this is the fun part. Yeah. So this is where you work on a model, where you handcraft your model. That requires a lot of skills. It requires a lot of time, and it will generate eventually a model, a single model, let's say, for a single product. Yeah. And that is something, it might be fun to do, but it's not something that really scales. So what would like to propose is you need a way to be achieved through automation. You need a way to, let's say, generate models for your whole portfolio, not just for a single model. And that also requires you to change the way how you work, actually. It needs to become more industrialized. Yeah, building models might become a commodity. Yeah, and of course, this is not only a change in mindset, it's also a change in the tooling that you have at your hands. Yeah, so you need the right tools to reach that, let's say, level or that stage of how you can, create and publish models. So, not trying really to define what ModelOps is, but just to give some hints, things that I think are important. ModelOps is about improving, streamlining, or fastening the process of bringing a model to production. Yeah, and the key for that is automation. At the same time, and we sometimes tend to forget that, it's also a cultural thing. Yeah, there's a cultural perspective to it. Originally DevOps, you all know that, that started as a cultural shift to improve the communication between groups, between developers and operations folks. Yeah, and in our case, it's not much different. I mean, we don't have like software developers, we have data scientists, but it's still the same task. We have to improve the communication between them. And this also requires your organization to be fit for that. Yeah. So if an organization, if your company is not set up to support that idea, your ops approaches might just fail. Yeah. That's not something that we can really repair. We are a software vendor, but I think it's an important facet to keep in mind. Yeah, and finally, I mean, ModelOps is a bit of a misnomer, yeah, to some extent, because as I said before, we usually think that it's not just about modeling. Yeah, single models are okay, but you probably will need to do more than just publish a single model to, let's say, a runtime environment. You will have to take care for the decisions that are actually executed based on your modeling outcomes. Okay, this picture, and then that's my final one. This is actually giving you an idea of what we are going to show to you today. Originally, it was animated, but Elders software can't do animations, so we had to skip all the animations. Yeah, so bear with us. You have to start on the left lower corner. Or in general, on the left side, you have the model development folks. Yeah, usually data scientists, they like to work in coding environments. They often communicate directly with their personal Git repository. There might be other data scientists, a different type of persona that actually prefers to work in a visual environment using a mouse. Yeah, it's both ways are fine. Both ways serve the same purpose. For our demo today, we are focusing on this coding approach, which you can see on the lower left. For today, imagine you're a data scientist. You work in a coding environment. You've been working on a model for some time now, and just today you are about to finish. Yeah, so your model is good to go. You think it's in a level, it's in a stage that you can actually promote your model to a central model repository. So we are introducing this central component in this picture. This is where all the, let's say, the good models are stored company-wide. We have a front end for that, and that's the SAS tool that you will see today. This is SAS Model Manager, but the basic idea is actually not depending on a specific software. It's the idea of having a centralized model repository. Now, how do the models get from your work environment to that repository? We are going to use an automation tool today. We are going to use Jenkins. That's a popular tool. I'm sure you all know about that. And the specific approach that we have been taking is that we this pipeline is actually already doing some checks. So if you submit your model to be included in the model repository, we are not going to just take it. Yeah, we are having a quality gateway in the middle. So we are testing your code. We are seeing if that code, let's say, has some hidden issues, if it's complete, if you have checked in everything that we require you to do, and only if that pipeline is successful, if the checks are successful, that pipeline will actually transfer your model to the model repository. So once it's there, we already know that this is a good model and it's compliant to our requirements, and so we can start again from here. Now we're a different persona. We are no longer a developer, maybe. And we can actually take your model and push it to a central Git repository, not the personal one, but let's say a central one. And again, have a separate, a second pipeline that creates, for example, a runtime container loaded with your model to execute some final tests in a pre-prod environment, in a staging environment. And if that's fine, we can do the thing again. Yeah, we have a workflow component that's part of our software suite. And we could use a workflow component and just actually take the very last step and say, now this model is fine. We've tested it. It's gone. It was compliant to our quality gateway, and now we're good. And this model is allowed to be published to, let's say, our production Kubernetes cluster. Yeah, so we could just use the same container and we push it to a different cluster. And this is where the model lives and where the model starts generating decisions, results, outcome. This is not the end of the story, because we need some kind of a feedback loop. This is also something that we are going to cover today. What this usually means is that we collect the data that this model generates, and we collect that data and we feed it back to our, you would have said warehouse in earlier times, yeah. But the idea is the same. You take the results, you feed them back into the system, and based on that data, you can make decisions in your centralized environment if your model is still fit for the data it sees in the real world. And if you see that your model gets worse, you see those exclamation marks. If you see that your model gets worse, you can take counter action, and eventually you go back to your data scientists and tell them, hey, you have to improve your model. You have to work on your models. And for today, and this is my final sentence, for today, we are trying to walk you through the whole circle, the whole life cycle. And this will be Tamara's part. Tamara.
Okay, thank you, Hans, for this overview. So, can you see my screen? Yes, I guess so. Okay.
Yep.
So now I will take you with me through the demo. Hans already summarized for you, and what you can see here is a way where I can start my model development environment, and you can see that there are running different pods, and I would like to develop my model with Python in this case, and so I would open this this pod here with a Jupyter Lab environment. I already opened this for you so you can see my work. And when you remember back to the paper of the Google guys, yeah, now we are doing the black box. Yeah, we are developing our model, and as you can see, it is already assessed by some KPIs, and I'm satisfied with my model, and now I would like to transfer all assets around my model to the central model repository. And for model governance purpose, I will write some metadata into this repository, which is on top maybe the work what I would do with my model. Yeah, I'm also writing into this model repository some information about my model. What are the input variables? What are the output variables? how are the KPIs when I trained my model, and so on. So I write some metadata. This is my last step here. And when I'm ready and satisfied, I would like to trigger a job, a Jenkins job. And I can do this with different Git commands here. And I have to go through 3 steps here, and I will run those now for you. So the first is just a configuration here. Now I'm committing my work into the Git repository first. And the third step here is now the one which will trigger the Jenkins pipeline for me. We solved this by tagging the Git project here. And through this tag, a special command is set up, and the Jenkins pipelines will grab this tag and run. And what will this Jenkins pipeline do when I submit this step? It will run some tests. And when you think about ModelOps in comparison to DevOps, we would like to do some advanced tests here. Not only looking for is the syntax well organized, is everything working so far. We would like to make some analytical tests as well, because with analytical models, you have to make sure that your model is really ready for real world data. Yeah, that you have, for example, thought about maybe bias in your model or other things. Yeah, when sometimes you have a delay between the training and the production run, so you have to make sure that your model can be applied to new data. So when I run this step now, this Jenkins pipeline that will be triggered by this step will make these checks. So now we switch to the Jenkins pipeline. And as you can see here, we have different Jenkins pipelines already. And one of our pipeline is the one which is called policy claim validation pipeline. Yeah. This is my project. I would like to predict if a customer is likely to have a claim or not. And so we look into this project. And now, as you can see, the Jenkins pipeline already runs here. And you see the different checks which are done within this Jenkins pipeline. Yeah. So now we are here at step 4, run model applicability checks here, and everything seems to be okay with my model. So, but maybe we can have a look at some Jenkins pipelines which were not successful, and we can take a look maybe if we can see what was going wrong. So we look into the log. And I think this one, maybe Hans has to help me here a little bit. If you can see the SAS log.
Yeah, if you, on which one did you click? Yeah, on the sync results, exactly.
Maybe
so,
this one?
No, so the idea is that basically we are running the checks, but we are first sending the results, the outcome of the tests back to the developer. Then we are evaluating the results in the pipeline, and then we are reacting on that. So we might then generate an error. So the error should have occurred in the center column, but we only react one step later, because we first want to make sure that the developer has a chance to see the results of our tests. Yeah. So if you want to show the SAS log, better go back to your development environment.
Okay. Thank you.
And just remember, this is build number 95. That was failed.
Yeah.
Okay.
So now, So the results are returned to me as a developer, and as you can see, we have run this very often so far, and I can take a look into the results into this folder here. And now you can see that we have the logs here, and the developer gets notified what was wrong. I get the log and different reports as well. And one is called FCE. FCE stands for Feature Contribution Index. And let's take a look what was wrong here. And you can see that we have a deviation between the blue line and the orange line here. So maybe the deviation was too big. And what does it mean? What is a feature contribution index? This is one of the analytical tests which I can do to make sure that the time when I trained my model and the data status of this training moment was the same, or is the same as I would like to apply this model to new data. So I have prepared this in a PowerPoint as well. So I will show or explain this on this slide for you. When we train our model on historical data, where we have the different features from number 1 to number n, for example, and we usually have an outcome. This allows us to train the model. And when we are ready, we would like to apply this model to actual data or new data. And usually, in this point in time, we don't have the true outcome. But can we apply our model to this new data? Maybe we have the delay between those two data sets is too large. Yeah? Maybe there are 1, 2, 3 months in between that you trained your model, and you and the status of the new or actual data is very different to the original or historical ones. So we have a so-called data shift in our data. And the feature contribution index allows you to compare those two data sets. And this is based on the idea that the covariance structure of those two data sets have to be similar in a way. And instead of comparing the covariance matrix structure, you can also compare just one feature and the prediction between the historical data and the actual data. And the two pictures here on the slide, on the left-hand side, you can see what happens if I have only a shift in mean for each feature. And you see the red lines here, dotted line. This is the confidence interval for the different shifts in my data. And you can see that if I only change the mean values of my features, then everything is fine. But when I change the covariance or correlation, yeah, then you can see that I get out of bound here. So this is the situation we would like to avoid when we bring our model into a production environment. If you are interested in these calculations, you can. I recommend you this paper, which is linked here on the slide as well. Another test could be to check if your model is biased or not, which means that you maybe prefer special groups in your data for a prediction, for example. And this calculation is very simple here, which is called a marginal effect. It tries to compare the conditional probabilities between different groups in your data. Can be different color of people or sex or something else. And this test is really easily implemented and can be a quality check for your model before you bring it into production. So now we were in the situation where we tried to avoid things which can go wrong before you bring your model into production. But what happens when your model is in production and you have a shift in your data, for example? Yeah, usually you make predictions, and after a while you get the true labels. And as you can see on the slide, you have different points in time, from Q2 until Q5, and you can see that you match the true outcome worse and worse. So it is to be recommended that you monitor your models over time. And at the end, when some thresholds are met, for example, then you have to make a decision what you can do with your model. You can redevelop your model completely. You can just retrain your model. You can go on with scoring when you say, okay, it doesn't matter or something like this, or you can retire your model. I just would like to give you an overview what comes with SAS Model Manager. This is also not something special to SAS software. You can have these different KPIs in other software as well. But I would like to differentiate between the situation when you bring your model into production and afterwards when your model is in production, and what you have to do with your model over time. We have different KPIs, and I've listed them here for you in one slide, just to mention a few of them. For example, when you know the true label, you can always measure the lift, Gini, rock statistics, and KS statistics. When you don't have the true label, you can monitor the distribution of your variables, or as mentioned before, the feature contribution index can be measured as well. So now I come to the second part of our demo, and I will focus on the model management part and model monitoring part, just to give you an impression how this can look like. So I will go back now to my environment. So what you can see here now is SAS Model Manager, and we already registered our model into the central model repository. Now, because our Jenkins pipeline didn't have any errors, it was brought into this central repository. And you can see here we have a project view. You can see different projects which are already there into this environment, and you can have different types of models or projects. You can have prediction models, you can have classification models, you can have text analytics models, so you are not restricted to a special type of analytical model here. But now let's take a look into our project here, which is called Policy Claim. And as you can see here, we just registered one new model here. This is with a time step of 5:30. And there are already two other models there. And one of these models is my champion model. So you can always compare those different models within this environment as well, independently from the model developer. You have also a versioning here available for your model. This is important for model governance, that you can always tell a supervisor, for example, what was going on with your model, for example. You can always click into the details of your model. For example, when I now click into this model, you see that all the information is collected here in this model. You have, for example, a scoring file. You have different files to run your model in different environments. You can see which variables are needed for this model, and you have some metadata here as well about how well your model performed during the training process. You can also see the variables which are needed here as well, differentiated into input variables and output variables, and you have an overview, what is your model about. can see, for example, who was a developer and what is the target variable, what is the target event, and so on. So now you already have seen the project view. Now let's look into the model view. Yeah, you can switch between those two views. Yeah? And now we see the models view. And you can see that there are already different types of models here within my repository. They are called R or Python. SAS data step models are here in my repository as well. Now I would like to search for specific models within my repository, and then you can click here. And for example, I would like to search for models which have the same target variable, which is called claim flag. I click on search, and you get all the different models listed here, which have the same target variable. From here, as already mentioned, you can compare your models, and I would like to compare those two champion models here, as you can see here. And you see, you get an overview first of your model, and then you have different information about the input variables, and you can see the difference here. For example, get some information about the fit statistics in detail or as a chart. So now let's go back to the project view and go into another project which was created by another model development tool and go through the other tabs here. As already mentioned, you have these variables and properties, but you can also, as an administrator of these models, you can also check here if your model runs technically in a specific environment. You can do this here, then the model would run into a SAS environment, but you can also test your models which you have already deployed to a specific environment. This is when you click on this publishing validation. When we deploy from SAS Model Manager a model into an environment, we call this publishing. So each time you publish a model into an environment, you get this publishing validation test, and you can run this test from here as well. But how can I publish a model from here into a specific model? There are different options, but I think in our demo overview, we mentioned that we would like to do this through a workflow component, which can be connected to each project here. And this would run here through this third view. Each developer can get a specific task on the whole project or model lifecycle. For example, you see here that my first task would be to import the model. This was already done when I triggered my model, my Python model with the Jenkins pipeline. So this model is already important, and I can go into this task and claim this task here. And then when I say, okay, this is completed now, I get the next test, the next task. Set champion and challenger models, and so on and so on. And one of these tasks can be to publish a model to a specific environment. This can be another test Kubernetes environment. It can be a production Kubernetes environment, or if you are working in another context, you have also the possibility to publish your model directly from here into a publishing destination. Just for demo purpose, I will show how this would work from here directly. You can just select a specific destination here, and you can deploy your model into this environment. How many destinations you will see here is you can, this is something you have to configure within your environment, and you can configure as many destinations as you would like to configure. So now we published our model into an environment, and we would like to monitor this model. And I just would like to show you how this can look like. Here we go into this performance report, and you can see that I can get different charts over the time here from the first moment when I trained my model into the fourth quarter of a year, for example. And you can, for example, the variable distribution, you can switch between those these variables here and see the different deviations. And also you can see that the feature contribution index is also directly here within this report. When you can also define some KPIs and get alerted if something goes wrong. And all these data are available for you so that you can build your own dashboard report on these data, and how this dashboard can look like for all your models which run in production. This is something we built up here with Visual Analytics as well, with SAS Visual Analytics, but you can use any dashboard tool you would like to use, just to give you an idea how this can look like. Yeah? For example, you can have for each model, I have two models here now, one which was created by SAS and another one which was created by Python. You get an overview about the health of your model for each KPI, which are here called characteristics, Kolmogorov-Smirnov statistics, lift, and so on. And if it's gets a specific status, you can have a coloring here for 0, 1, and 2, for example. Or as you have already seen the charts, same charts here, but I can switch between the different models here. And also you can bring in your own reports, how, for example, if you would like to see the misclassification rate here in a tabular form, you can create those charts here. So I think this was what I would like to show you in my demo, and I think we can go back to the summary. And now I would like to ask Hans if he would like to make the summary.
Yeah, not a big deal, huh? So what did we show to you today, or what actually what was the goal of today? So we've been working in containerized workspaces all the time. You didn't notice probably, but all of this stuff was running on a Kubernetes cluster. We've showed how you could set up a model validation pipeline using an automation tool. I've already seen one interesting question in the chat. I'm eager to answer. Yeah. We've shown you the value, hopefully, the value of having a centralized model repository. Yeah, where you can store all your models, and finally, the value of having a visual way to get a feeling for the quality of your live models. Yeah, so the model performance dashboard that lets you get that gives you the information about the behavior of your models over time.
We have questions. So basically, the Lucas was asking. It's not really like the question, but just asking if it's possible to see the Jupyter notebook and some projects which are probably publicly accessible.
That's
your projects, as I understood.
think, Tamara, that's for you. This is our sample codes. I don't think it's very fascinating. Yeah.
Yeah. Actually, it's not somewhere publicly available, but I can send you similar Jupyter notebooks if you like.
Yep. So if you stay for the close-up session, that we can decide how we will arrange it logistically. So we have a question. We have basically two questions from Lana Kolakovic. So Lana is asking, how do you keep track of which data was used for which model, and how can a model be reproduced?
Okay, I think this is a question for me. You can always, for example, document which data were used. You have to add this information into the repository that you know where the data are coming from. And for retraining, we have different options. If you're in a SAS environment, you have a retrain button. If your model comes from SAS, you can just click on retrain. If you're creating your model with Python, you have to do this on your own. You have to find a solution for this scenario that you have to retrain your model. But our idea is that you save all your work as well in a Git repository for this purpose, that you can freeze your work in a specific status, and if you would like to retrain it, just grab it from there and apply it to new data and register your model into the model environment.
Okay, since we had demo, we have quite technical questions, or for example, how to do this or how to do that. And Vivi is asking, how are the checks made? Does the Jupyter notebook you committed contain tests?
Let me see that question again. So if I understand it correctly, the tests are not, in a strict sense, they are not part of the model contained. So this is not something that lives on the end of Tamara. So we basically inject the tests during the validation pipeline, during the automation pipeline. So this is something that comes from a central space, and it's applied during runtime, during check time, or to the model. Yeah. So this is not something that Tamara has written. I hope I got it right. The question.
Yeah, Vivi, if it's not, if it wasn't the answer, just
Please
write in the chat. Another question from Lana. I see you are using Azure to run your SAS Model Manager. What is the benefit of SAS Model Manager in comparison to what is provided natively from Azure?
Well, to be honest, I'm not sure what Azure ML service is offering, but what I've seen in different software tools is not the capability that you have all these information about your models, whereas what are the input variables, what are the output variables, which KPIs are used, and the way how you can collaborate with each other, and that you can track everything through a workflow component, for example. This allows you that you can, if there's a supervisor who would like to know what was done with your model, you can always tell them who did which step on the whole process. I think this is, I haven't seen this combination of a workflow process with other comparable tools so far. And maybe that we can, with SAS Model Manager, we can really combine every type of model and bring them under a hood. Yeah, not
And
only open source models.
Yeah, and you work at SAS, that's why it's logically also. Jonas is asking, it was at the very beginning, this question was, I think, after 5 minutes since your talk started. Why don't you have a GitHub hook to trigger the Jenkins pipeline automatically?
That's a great question. I like that. Actually, it would have been possible. We could have been doing this. Yeah. It was actually more from an historical perspective. When we developed this showcase, it was for a customer, and that was his favorite tool, basically, Jenkins. Yeah. So there's no real technical reason why we did it this way and not the other way around. Yeah. But you're completely right. You could have done it differently.
Just a moment. So till now we don't have questions, but I just launched a poll and I'm sharing the results publicly, so you should be able to see it in the chat how familiar you are with Kubernetes. And I asked this question because I was not personally working with Kubernetes, but I heard a lot about this and like a bit of the history, like that it comes from Google developers, if I'm not wrong. But can you explain, like for people who have no experience with it, why this word is everywhere? Everyone is talking about Kubernetes. Maybe a few just quickly explanations why it's so popular also in the industry. It's not only in the developing environment, but also it was so quickly implemented, as I understood, in the industry.
So this is a question for me. Yeah, Elda? Well, I mean, I think we all are aware that Kubernetes has made a big start over the last year. So it became much more important, and the big companies have jumped on that train. Yeah. So originally Google released it, then it became open source, it became popular. Now you have a lot of different Kubernetes distributions on the market. Yeah, on-premise, private cloud, public cloud, hybrid cloud. I think the big advantage is it takes Docker one step further. Yeah, so Docker is fine. So this Docker approach already covered a lot of open issues that you could not really solve with pure desktop. No, sorry, with pure virtualization. Yeah, running virtual machines is in the end quite costly. Yeah, and especially if you have to scale. Docker was a good step in the right direction, but still, if you wanted to scale out, and I mean, you see our platform, for example, runs on Kubernetes now, and it contains 130 pods. Yeah, and that's just the number. Yeah, and this is in idle state. Yeah, before people start working with it, and you can't simply administrate this level of containers without a stable and robust infrastructure. And that's actually what Kubernetes brings to the table. And just to add one more thing, for me personally, as an architect, one of the big advantages is that Kubernetes abstracts to the layers below. Yeah, so basically, if you just as an application, you just talk to Kubernetes and tell Kubernetes what you need, and Kubernetes takes care for getting it. Yeah, so if it has to reach out to the Azure infrastructure, or to AWS, or to your local data center, it will just do it, and you don't, as a developer, you don't have to care. Yeah, you just say, hey, I need some shared storage, and it gets you the shared storage. If it's on AWS or on Azure, who cares? Yeah, and that's a big thing, and I think this is one of the main causes why it's so so popular. Yeah.
Yeah, thank you. And the last question, because we are almost we are actually around of time, but I cannot ask you this question from Jesus Sanchez. I will read that because there could be some details that I don't want to miss. How does the development environment for the data scientist looks like? Is it running locally on the computer, or is it hosted environment? Like, for example, in a container on a server or cloud? Are they on-demand environment, and are the dev environments managed as models are? So many questions.
So maybe I can explain what we did here in our demo. We this environment was not running locally. It was running, I started it through this, we had a list of pods in the beginning. So this was running in the Kubernetes environment with many different pods, where I can choose between a Python environment or an R environment or a Python environment with different versions and so on and so on. So this was really running in a cluster environment. I think this is when we are talking about open source or model development in an open source context, we need something like Docker or Kubernetes, because you have so many different requirements and dependencies which can't be brought under one hood. Yeah, so the solution is to use Docker and Kubernetes clusters for this scenario.
Yeah, but on the technical end, just to add to that, technically, we could have worked locally as well. As long as we check in our codes, our results to Git, the whole processing would just be the same. Yeah, but of course, it's a huge difference from an IT, from a governance point of view.